Well, I didn't get to introduce myself. I think most of you know me. I'm Susan Zellers, and I have the good fortune of acting as the program director for Ocean Exchange and working with Millie every day. So the agenda says we're here for a blue economy startup pitch competition. But this next hour is so much more. This is not just a pitch competition. It's an opportunity for you to see the who, what, when, wheres that are going to carry us forward into this new ocean enterprise, this brave new ocean. The $25,000 purse that they are competing for is provided by the National Marine Sanctuary and the EarthX. And you're going to see 7 superstars that are working in this ocean enterprise space, this subset of the blue economy. 3 in data generation, 2 in water and waste management, 1 each in robotics for sensing and predictive analytics. You're going to see Actea with their innovative ocean climate modeling, atdepth with their digital twin ARI, Ceretune, which combats nutrient pollution but uses biomass growth and water chemistry to guide them. Fathom Science generates ultra-high resolution wave and weather analytics. Nucleic sensing systems develops autonomous field deployable tools that analyze DNA and RNA to detect and mitigate pathogens and invasive species. Onvector destroys the PFAS and using their proprietary plasma vortex innovation. And Salient leverages data with machine learning to deliver accurate weather forecasts. I know you're going to be just blown away by what you're going to learn. So we have this set up much like Ocean Exchange. We call it a little mini Ocean Exchange. We have presentations, and then we have discussion groups at the round tables here. So these discussion groups are what act as an accelerator of sorts. So you will have the opportunity to have the startups at the table, to tell them what you didn't hear, give them suggestions, ask them any questions, and as they move around through the tables where you will stay in each table. The startups are going to appear alphabetically by their company name. They're only going to have 5 minutes. And I'm not going to be the one that yanks them off. That'll be Dane. He's really good at that. And we're going to run through all 7 presentations with no time for questions and answers until the end when you have them in the groups. The breakup tables will be organized kind of randomly. I'll be herding you to them and giving you the opportunity to discuss what you heard. And before you leave, I'll give you a ballot, and you will mark who you think deserves that $25,000 award. We're going to use the same formula we use on Ocean Exchange. We're going to ask you to think about what's the impact of this on the oceans. What's the innovation? What's different from the other people working in this space? And what is their ability to execute and make this work? What's their ability to scale this and make it work? So that's it in a nutshell. I'm going to start by introducing Actea, Jordan Miller.
Hi, my name is Jordan Miller. I'm the co-founder and CEO of Actea. Actea's mission is to utilize the ocean for positive economic growth in the face of the changing climate. We get our name from Greek mythology. Actea is the narrative of the rocky shore, a protector of fishermen. In addition to the invaluable ecosystem services that the ocean provides all of us that were discussed earlier today, the ocean also provides tangible dollar value to industry, wild capture fisheries, mariculture, the finance that underpins them, and the emerging field of marine carbon dioxide removal, which is small today but could scale to be a $1 trillion industry. All these different uses are interrelated, and they are all impacted by ocean conditions. And Actea's kind of core thesis is that the ocean is now changing so quickly, it is no longer sufficient to understand how the ocean behaves today or how it behaved in the past, but you need to understand how it behaves in the future. And I don't mean on the timescale of a weather forecast for a week or a year, which are very important. I mean, what will the distribution of potential ocean weather be in 5, 10, 15, 25 years? This is what an Actea model output looks like for the coast of Norway, for the cod fishery there. If you're thinking about spending tens of millions of dollars on a species-specific processing ship, you might want to know if your target species will still be in your waters in the over the lifetime of that boat. We're also helping Newfoundland site marine protected areas in order to preserve the cod fishery there. And we're working with the Quinault Indian Nation to help them understand, as fish move out of their area, what other species will come in so that they can diversify their fleet and maintain revenue in the face of this change. This is another Actea data product. Here you see 100,000 different aquaculture sites from all of the salmon farming countries of the world. And we've looked at the conditions in the 2000s and 2030s and understood how each site will change its performance in that time. And this type of data can be put into a spatial planning system to allow aquaculture farmers to understand where they should allocate capital for specific types of interventions. It also allows them, because it's both high resolution at 1 kilometer, but also a global model, it allows questions such as, will there be a simultaneous cash flow loss in Chile and Norway, and how does the probability of that change into the future? That allows you to understand how you can leverage your business or how you should price insurance or reinsurance. And the same data that underpins these climate projections tied with habitat, species habitat models, we've also developed a system to put it into marine CDR or marine carbon removal modeling. So we've developed a novel model called a Lagrangian flux model that sits on top of our machine learning derived outputs. It could also sit directly on top of observations. And it uses Lagrangian tracking for understanding where an intervention goes in the ocean, and then biogeochemistry to understand how it evolves with air-sea flux. This can model efficacy and environmental interactions. And it can be combined with these other models with aquaculture and wild fisheries so that you can understand questions like, how will marine carbon dioxide removal in the Aleutian Islands impact crab spawning in the year 2030? Or I'm building, where should I site my ocean alkalinity project, given that there's a coral reef here and there could be a co-benefit from a certain spatial reduction in pH. So to conclude, our goal at Actea is to make this type of modeling affordable enough that everyone who's doing anything in the ocean can become climate informed. We can understand how best to optimally place all these different technologies in the ocean for different uses. Where should you put coral you're restoring? What species of eelgrass should you put at a certain place? Where should the marine protected area be? And how should this work with increasing pressure from aquaculture and marine carbon dioxide removal? Thank you for your time, and I'd love to answer any of your questions afterwards.
Thank you, Jordan. Really great. Next, at depth, Suki Wong presenting. Suki? Green button in the center.
Hi everyone. Okay, you can hear me okay. My name is Suki. I'm the head of Ocean Intelligence or head of science at Depth. So today we're entering a new era in how we can work with the ocean, an era where every decision can be backed by a digital twin of the ocean. So at Depth, we build ocean digital twins for every ocean activity. Today, there are many new ocean industries emerging, from CO2 removal operations to seaweed farms to coastal restoration and conservation markets to aquaculture. The ocean is teeming with all these opportunities, but there's a critical problem holding these industries back. It's that they lack actionable information. In other words, ocean industries do not necessarily get the data they need to succeed, and that's because ocean sensors are expensive, the data they collect are sparse. Meanwhile, legacy ocean models are not that scalable. They take months to set up and are slow to run and are expensive to run. So these companies waste resources with high operational and capital costs, weak scalability, low yields, and this limits their growth and access to new markets. We can't keep doing this. We need to actually find out what's going on with our ocean activities and for it not to cost so much. For example, a single monitoring suite can cost about the same as a brand new Toyota Camry, and yeah, that's just to measure one single data point in the ocean. So at Depth, we're redefining ocean digital twins. we're solving the need for actionable information with validated digital twins on demand at any scale, from 1 meter to 1,000 kilometers, anywhere. We're combining monitoring data with next-gen GPU-based simulations. That makes it 100 times faster and 100 times cheaper than existing solutions. So what once required months and months of work by specialized teams can now be launched overnight. Our simulations couple the ocean with your intervention so that with fully coupled ocean processors, the data is actionable and it responds to your real-time activity and decisions. So let's see what this looks like. Here's a snapshot of our digital twin of a kelp farm in Namibia. We can look at the ocean temperature if we want, or the salinity, the pH, or the concentrations of carbon dioxide in the ocean. These are not just colorful pictures. These are from simulations that are validated with real-world data. And we also deliver tailored metrics that matter to our customer. So in this case, it was the farm conditions, the kelp growth rates, and the carbon sequestration performance by the kelp itself, and the CO2 removed from the atmosphere during the operation. For this customer project, we deployed this twin in less than 1 month, and it was used by our customer as finalists in the X Prize $100 million carbon removal competition. Here's the really cool part. The cool part here is we delivered this twin, the full year of digital twin, in just 48 hours of GPU runtime. This means we can already scale our services to hundreds of customers simultaneously. Now let's switch to another customer project with a more local view. Here's another digital twin of a carbon dioxide removal operation in New York City. Here we can see the real-time mixing as a snapshot around their operation, and we can look at this from any depth we choose. So what does our customer get with this kind of extraordinary level of data? Our customer gets a three-dimensional view into the operations performance, including local water quality conditions that respond to their operational choices. And they also get carbon removal metrics that we calculate that are needed to put carbon credits on the market. So this is what we do. We build digital twins for every ocean activity. We're deployed around the world, and we provide our customers with tailored, actionable metrics. And we have made ocean intelligence as a service, as a key-in-hand service, a reality. And this is all thanks made possible to our amazing team at atdepth and with the support from our strategic partners. So far, we've raised $5 million in non-dilutive funding, with our revenue growing from $235,000 in 2024 to $675,000 in 2025 to date. Thank you so much for listening. Happy to answer questions later. Thank you.
Thank you, Suki. Great job. Next, Ceretune. Presenter, Reid Barnett.
So I'm good to go? Awesome. So my name is Reid Barnett. I'm the founder and CEO of Ceretune LLC, where we are in the business of turning pollution into possibility. The problem that we're looking to solve is cultural eutrophication. To call this problem massive is a massive understatement. The United Nations estimates that cultural eutrophication costs the global economy up to $3.4 trillion annually. And if we just look at the United States, the EPA shows us that we lose about $1 billion of tourism. We have an 80 times increase in our water treatment costs, a 25% reduction in real estate values, and lose tens of millions in fisheries every single year. It also is a very large reaching problem. It's not invisible. We see it, we know it. There are 3 engineering grand challenges devoted almost exclusively to this problem, and 13 of the 17 United Nations Sustainable Development Goals are also addressed in cultural eutrophication. And with all of this, there's still no effective and scalable method to remove this pollution from the environment and to remediate it. Well, until now. Our solution is the fibrous aquatic bioscaffold. It's FAB for short, or fabulous, whenever you find out what it can do. It is basically a fabric. It's a nonwoven, it's a buoyant fabric that floats on the surface of a body of water to grow plants from seed. As these plants grow, they pull nitrogen, phosphorus, and other pollutants out of the water, basically anything that can bioaccumulate in a plant, and carbon dioxide from the atmosphere. Per acre, we can get about 1 metric ton of nitrogen, about 200 kilograms of phosphorus, and about 40 metric tons of CO2 removal. And when we're done, the entire system, material, plants, and all, can then be removed and post-processed into a secondary market, secondary goods. We can generate about $6,000 worth of biochar per acre, about $5,200 in carbon credits in that same space, and at least in the state of North Carolina, our nutrient offsets are valued between $60,000 and $650,000 per acre, depends on your watershed. And did I forget to mention that it only costs us about $1,500 to make it, and about 11 minutes flat. We install it in 30 and remove it in 45. Now, because what we do is so broad, our market is sort of a conglomeration of a lot of different ones. Total market size for what we're looking to do is about 1.2 trillion. About 80% of that is made up by carbon credit market, but the other 20% is broken down between compost, biofuels, mitigation banking, and environmental services, all of which we're able to do in one simple, sleek package. To say we have customers is a little misleading. We're looking for partners. We can work with any group, individual, organization that's looking to remove their pollution from the environment or just reduce the amount of pollution in general. This could be government agencies like the EPA, the North Carolina Department of Environmental Quality, who we've been working kind of closely with, industrial partners, environmental engineering firms, and farmers. Hog farmers in eastern North Carolina, which is where I'm from, if you couldn't tell by the voice, is actually one of the initial markets we're looking to get into. And because we can make so much on the secondary market for this in relation to our cost, we're even toying around with a business model that allows us to pay people to take their pollution instead of charging them, which eliminates almost all of the barriers to a lot of the solutions that pretend to, or that exist today. We can erase all of those. Our technology right now is, we've had very successful proof of concepts, and we are rapidly approaching full manufacturing and full prototyping phases. And by rapidly, I mean like in the next 2-3 weeks. Depends on when the fiber arrives. We are developing, our research right now is in developing the specifics for our construction and composition of the material, as well as the plant types, so we can be as effective and as efficient as possible in nutrient removal. We're also looking into the various commercialization opportunities so we can really get the most bang for our buck. We've looked very strong to biochar, biofuels, some agricultural goods, but there's a lot of other opportunities we want to expound upon. Okay, the team so far is comprised mostly of myself. My awesome CSO, Blake Parrish, is in the back today. My PhD advisor and mentor, Dr. Philip Bradford, who has been an extreme help, as well as strategic support from NC State through the Nonwovens Institute, the Wilson College of Textiles, and the North Carolina Plant Sciences Initiative. Here at Ceretune, we are looking to not just eliminate the pain of pollution, but to turn it into one of the greatest opportunities of the modern age. Thank you, and I'll answer questions later.
Thank you. Next, Fathom Science, Taylor Shropshire. Taylor, there you go. Big green button.
All right. All right, good afternoon, everyone. My name's Taylor Shropshire. I'm an oceanographer and a founding member of Fathom Science. Fathom Science is an ocean forecasting and marine data analytics company based out of Raleigh, North Carolina. The problem that our company is aiming to solve is that there's a lack of ocean information for supporting conservation decisions and marine operations around the world. What do I mean by this? Ocean information includes any actionable insights into ocean currents, waves, and wind conditions now and in the future. Without this information, economic growth of the blue economy will continue to come at the expense of our oceans. To put this problem into perspective, think for a moment how the world would be impacted if there were no dependable weather forecasts. This is the reality for much of the ocean. Our solution is to democratize ocean information using scalable met-ocean forecasting. Scalable, meaning that anyone can use our software to generate hyperlocal, personalized ocean forecasts anywhere on Earth in a matter of minutes. Met-ocean, meaning that our models simulate the ocean, the atmosphere, and their interaction to provide a highly realistic digital twin of the ocean. Although it may seem obvious that the ocean influences the weather and the weather influences the ocean, The reality is that historically, many times these models are run independently due to computational constraints. At Fathom Science, for the first time, we are combining coupled Earth system modeling with AI and data analytics and cloud computing to provide actionable ocean intelligence. The company was started in 2024. We are a spin out of NC State University, and we're now leveraging decades of research to develop software products that increase the effectiveness of conservation efforts and improve the efficiency of marine operations. Although we've had a lot of progress in commercializing our products in the marine operation space, today I'll highlight two of our newest marine conservation products. The first is DriftCast. DriftCast can simulate the transport of any drifting object in the ocean. This is an image from the website you can go on right now, driftcast.fathomscience.com. Currently, DriftCast is being developed alongside fisheries managers at both the federal and state level. Each year, fisheries managers have to set sustainable fishing regulations. One of the challenges in setting these regulations is understanding how many of the fish eggs that are spawned in a region are retained by local currents. DriftCast allows fisheries managers to track the transport of fish eggs from known spawning locations. This information has the potential to revolutionize how wild fish stocks are managed. DriftCast is also being used to track marine plastics in the ocean. This is an image from satellite imagery that our team has processed. We're using image processing with machine learning to identify marine plastics. And then once we've identified them, we can track their movement using DriftCast. This allows us to support more efficient removal strategies and identify areas of aggregation. DriftCast is also being used to simulate seaweed farms to quantify marine carbon dioxide removal in Indonesia. It's long been recognized that seaweed farms offer an efficient CO2 removal strategy. However, measuring this in the field is expensive and challenging, as we've already heard today. At Fathom Science, we're using DriftCast to simulate the transport and sinking of seaweed from farms to better estimate marine carbon dioxide removal. This has the potential to unlock enormous value for seaweed farmers around the world. The second product we're highlighting here today is WhaleCast. Everyone is probably well aware that marine traffic is continually increasing. As a result, we're seeing more frequent vessel strikes. This is despite the fact that there are many websites that show recent whale sightings. We have to go a step further. WhaleCast utilizes thousands of historical sightings, survey data, and Fathom's ocean model data to develop a machine learning model to identify high-risk areas. This example is for the Gulf of Maine for the North Atlantic right whale. DriftCast will provide the first hourly risk forecast to inform mariners of risks in their area so that they can make decisions on the water. We're already in conversations with some of the largest marine electronics companies in the world to make this data accessible. Our team is in place and ready to expand DriftCast and WhaleCast, as well as other Fathom Science products. We have 12 team members, 6 PhDs with a tremendous amount of experience in ocean modeling. We also have a proven track record where we've brought in over $20 million of R&D funding. And together, our experience and our proven track record positions Fathom Science to be an industry leader in ocean forecasting technology. Thank you.
Sorry. Next, Nucleic Sensing Systems, Ed Rudberg. Ed, big green
Thank you,
button.
sir. Hello, everyone. Like I said, I'm Ed Rudberg, and I'm the CEO of Nucleic Sensing Systems. And we're developing the world's first continuous autonomous biosensor based on droplet digital PCR technology. And I know that's a lot of science for this time in the afternoon, but I promise that I'll go through it more. As a society, we're facing environmental and health catastrophes without the real-time detection and ongoing monitoring of biological species of concern. In our oceans and waterways, invasive species cost the world's economy in excess of $400 billion per year. In animal health and welfare, in aquaculture, disease costs those producers in excess of $5 billion per year. And the inefficient management of wastewater results in a 100% increase in greenhouse gas emissions. And when you look at biomanufacturing, many of these facilities are as little as 30% efficient. We do a really good job of monitoring physical and chemical parameters, but I'll tell you what, as a society, we're doing a garbage job at quantifying biology. What I envision is a world in which we have sensors throughout the blue economy that are pushing data to the cloud that quantifies environmental DNA, whether that's in our fisheries, aquaculture, energy sector, or in wastewater. The solution is the tracker. So let me step back a little bit. What's environmental DNA? Well, we're all shedding cells into the room right now. Fish swimming along does little onesies and twosies. It's shedding cells into the environment, right? And those all include DNA. And when it's in the environment, that's environmental DNA. So what we've done is we've taken a technology which is droplet digital PCR, which I know, a lot of science, but it's like swabbing your nose not once to tell you if you have COVID, but swabbing your nose 20,000 times so you can quantify genetic concentration. Now for the ocean, that's swabbing the ocean's nose over here and looking for otters and urchin and kelp, or going over here and swabbing the ocean's nose, if you will, for E. coli, for right whales, and for anchovies. And we can do that totally autonomously. So we've taken a laboratory equipment, we've put it into a box, we've taken it into the field, and we've taken the human out of the equation. And you can get results within an hour. So that data provides key customer benefits, rapid detection. So we can give data to our customers in less than an hour, not weeks or months. And we have ongoing sampling effort without any additional human interaction. And that more data results in better management, rapid response, and resulting in the safeguarding of human health and the environment while saving on operational costs. So says Daniel Florenson, disease is one of aquaculture's greatest risks, and S2's ability to test in-field automatically will be game-changing. We've had a ton of traction in environmental monitoring. We've had case studies with the Fish and Wildlife Service, National Park Service, Pacific Seafood, who is one of the largest aquaculture producers in the United States, sold a prototype to the USGS, and we've raised over $1 million in NOAA SBIR 1, 2, and 3 funding, and the USDA SBIR 1. We're entering 4 distinct markets, which includes environmental monitoring, global aquaculture and animal health, water and wastewater, and biomanufacturing. We've been recognized universally as a leader in both water tech and blue ocean tech. So why do we lead? Well, precedent technology is to take a water bottle, dip it into the water, send it off into a laboratory, get results in weeks, if not months. We give real-time results within an hour. And that 24/7 monitoring gives the baseline data that empowers AI, machine learning, and predictive analytics. The team is made up of myself. I have a PhD in natural resource science, master's in marine affairs and policy from the University of Miami, and my business partner, Mark Affelbacher. And we've been in business together for the last 15 years, in which we've taken conservation-focused businesses and brought them to international distribution. We make money in 3 distinct ways. The first, equipment sales, and then the razor blade model in both SaaS and post-sales via service consumables and reagent consumables. In summary, we have the world's first field-deployable biosensor based on droplet digital PCR technology. We have an iterative multi-phase business plan to reduce risk and gain early traction in the marketplace. And we have significant addressable markets, which includes at least 3 multi-billion-dollar domains. If you're interested in biosensing, we'd love to talk to you. Better yet, if you have a fund and are interested in biosensing, find me after. We're doing our seed round. So I thank you for your time, and I look forward to the conversations.
Thank you, Ed. Appreciate it. Next is Onvector. Daniel Cho presenting. Big green button.
Good afternoon. My name's Dan Cho. I'm the founder and CEO of Onvector. Onvector is a water and wastewater treatment technology company using plasma. Plasma, which is ionized gas, or arc lightning in our case. I founded Onvector after I left Drexel University's Plasma Institute, realizing that there's a need for next-generation chemical-free water and wastewater treatment technologies that are powered by electrification, but also more robust than UV and ozone. Plasma treats a wide range of contaminants. We're focused on PFAS. Just by a show of hands, how many here are familiar with PFAS, per and polyfluoroalkyl substances, forever chemicals? Think Teflon, Scotchgard, Gore-Tex. The carbon-fluorine bond is one of the strongest in all of chemistry. So these are incredible performance materials, providing protective coatings in numerous household and consumer products, but also essential for manufacturing of semiconductors, firefighting foams, and other industrial goods. The problem is, the same property that makes PFAS so useful also makes it hard for the body to clear them. So they bioaccumulate, and they've been linked with numerous disease states, including several cancers. Onvector is solving this problem with plasma vortex. This is a plasma hydrocyclone delivering high-energy electrons inside flowing water that break the carbon-fluorine bond. This is the lowest cost, most effective PFAS destruction technology available, with no harmful emissions or byproducts, at low temperature and low pressure with no expensive consumables. 7 patents have been issued and 3 more pending. Our markets are broad because of the ubiquity of PFAS. You might be thinking about regulated water, taking PFAS out of municipal drinking water. That is an important market for us in the future. A more immediate market is environmental remediation. There's tens of billions of dollars of cleanup necessary at industrial sites where they've used or manufactured PFAS, or at military bases or airports where firefighting foams have been sprayed. An even more urgent beachhead is environmental services, this AFFF foam stockpile that needs to be destroyed. These firefighting foams are no longer manufactured. They are difficult to insure, and they're being swapped out for fluorine-free foams all across the country. Onvector is attacking this market for using a destruction as a service model, DAAS or DAS, where we are charging on a per gallon rate. We've already gained traction through bench tests and paid pilots, and we're opening up our first permitted site early next year. Here we show a case that's published just last week in Environmental Science and Technology of a coastal aquifer discharging into the Atlantic Ocean at Joint Base Cape Cod. We remediated 300,000 gallons of contaminated groundwater using our technology in a successful field pilot. We use liquid chromatography to monitor PFAS down to the low parts per trillion level, as well as fluoride on-site to monitor performance. As I said, plasma vortex is the only PFAS destruction technology that is low cost, low pressure, low temperature with no expensive electrode materials. There's no emissions, and it completely destroys and mineralizes PFAS. We're excited to open up our first permitted site early 2026, and we are expanding into other markets thereafter. The technology is TRL7, moving rapidly into TRL8, and I've assembled an excellent team that includes proven veterans from Xylem and Veolia, as well as PhD engineers. We're raising our seed 2 for $8 million. Thanks so much for your attention.
And now, Salient predictions, Raymond Schmitt. Big green button.
Thank you. Thanks, everyone, and thanks to Ocean Exchange for sponsoring this little pitch. Yes, I have a long career as a scientist at the Woods Hole Oceanographic Institution studying the global water cycle, and I discovered there was predictability for rainfall on land from the variations in ocean surface salinity. And in 2016, I found out about a rainfall forecasting contest that the Bureau of Reclamation was sponsoring. My identical twin sons are machine learning engineers, and we decided to enter this contest. It was a kind of a strenuous year-long contest. We won, walked away with $250,000. So we decided to start a weather prediction company. We got, here's our scores in that contest. We were twice as good as the nearest competitor, which was a professional forecasting company. The NOAA model was a little better than climatology. We've put together a really strong team, and we've got to address the increasing weather volatility that our climate system is giving us. I mean, just look at the last 6 months with wildfires in LA and flooding in the Midwest, tornadoes. Businesses and people need longer range warnings of such disruptive weather. What we're doing, we build a very sophisticated dashboard and API system that provides global probabilistic weather forecast. It allows comparisons with NOAA and ECMWF forecasts and enables customers to build specified alerts for better business predictions. We've got a really sophisticated dashboard to analyze the forecast. We forecast temperature, precipitation, heating degree days, cooling degree days. Those are for energy demand, solar insolation, hydropower, and 100-meter wind for wind force. So we're doing renewable supply and energy demand. We were really the first operation to show that AI could be successfully applied to what's called the subseasonal, the seasonal forecasting domain, weeks to months ahead. A lot of people are in doing that now, but we've remained ahead in skill and usability. One of our grants, we've had grants from NOAA, NSF, and the Gates Foundation. And when Gates found out about it, he said, how do we know Salient is the best forecaster? So they very recently ran a competition. We're improving our model constantly. We're still ahead of the game. We bested Google, Tomorrow.io, Brightband. We came out on top again. One of our competitors said, the Salient model is so strong. I've never seen anything like it. We release a new model every 6 months, and our latest pivot is to natural gas, energy, and commodity trading. And this goes back to the 2021 outbreak, February of 21 in Texas, where basically the energy supply system broke down because of cold air outbreak. After it happened, we looked back at our forecast, and a month ahead, we could see the freeze coming. We're there on the left. At the same time, same forecast date, NOAA and the weather company said it was going to be warmer than normal. We could easily see it was going to be colder than normal. And so this slide's been a good selling point for us. What we claim is that we are far more reliable than the NOAA forecast. Reliability is in that central diagram. What you want to see is a 1-to-1 slope there, the 45-degree line. NOAA tends to overemphasize extreme events. Maybe that's intentional. Anyway, we are better calibrated. Our forecasts actually look like the real statistics that happen. And we provide a probabilistic forecast, so we can tell somebody, there's a 40% chance of heating degree day requirement for Dallas being above 50 in the future. What does this mean in practice? So here's looking at 18 US airports, the temperature maximum anomalies. The NOAA GEFs, they fall off the 45-degree line. Our new Salient GEM model falls right on it. As a practical matter, that means NOAA is often putting out false alarms. So this is looking 20 days ahead. You see they regularly spike up in, this is I believe it's the heating degree days in, heating degree days in Dallas. And what that means is that the NOAA forecasts often move the market. If you look at the Henry Hub natural gas prices, we'll show you what happened in one particular instance.
Sorry, the time is up.
And we can produce a forecast that's more reliable, and it comes out sooner. So it's a perfect thing for natural gas traders.
Thank you. Appreciate it. All right. Now it's in your court. Susan?
Well, we're going to bring you all forward to these tables. We hope to have 8 or 6 to 8 around each of these tables for you to discuss what you've just seen and to help us choose who gets the money. Before you leave, I'll give you a ballot. You can mark it, give it right back to me, and I will be counting them before the banquet tonight where we will award this. So please come forward, sit with people you don't know, and invite the startups to come over if you have any questions or anything else you want to know in order to make your decision about who gets the money tonight. Questions? All right, let's go.
So I want to thank everybody. There's a happy hour out there, I hear, and then there's a banquet tonight. If you can't come to the banquet and you're curious who won, text me or Susan, and we'll let you know. Or look on LinkedIn. We'll put it on LinkedIn if you follow LinkedIn. So I want to thank everybody. I hope that we all learned something today. Hey, Susan, can we put that word cloud up? Let's see all the words that it's gone. The word cloud went in the clouds. Okay, but I want to thank everyone. I appreciate the engagement. It's a very long day, and for some people here, it's a very long week. So those that traveled, thank you all very, very much. Enjoy the rest of your time here, and I hope you made some new connections, taking home at least new LinkedIn connections, new business cards. Thanks so much. And I want to thank the EarthX folks. I want to thank the AV crowd. You guys are awesome. You tolerated a lot of last minute stuff. Thank the people that manned the doors and helped us in every way. It's just been wonderful. Thank you so much.